Before we begin, we just want to be clear. The following video is not a projection. It's just an exercise to explore what may happen in a pandemic and government strategies to contain it. China's Lunar New Year celebration is the biggest human migration on Earth. Millions leave the country, all using planes, trains, and crowded buses. A new virus has emerged at the worst possible time. It's called 2019 nCoV, or novel coronavirus. The CDC thinks it started with an animal source, but has since become airborne, spreading from person to person by coughing and sneezing. In some cases, pneumonia and kidney failure kill. What began in central China is now in the Western U.S., India, and Thailand. North Korea has already shut its borders. We don't know how bad this will get, but consider this. An Imperial College London report stated the outbreak has caused substantially more cases than currently reported. So we thought, what if we used a video game to simulate a worst-case Chinese New Year? And what should governments do to stop it? We're a new science channel. Subscribe to join us. First, we created our own scenario to mimic the current outbreak. We upped travel frequency to simulate the New Year migration. This causes an immediate issue. Countries are really resistant to close their airports, in the game and in real life. A 2015 study from the CDC analyzed this. It looked at the 2003 SARS and 2009 influenza pandemics and discovered they preferred border screening. However, there's a problem. The CDC found it was, quote, not effective at detecting infectious persons. There are no airport shutdown regulations, and we can imagine some economies would be hesitant to do this during holidays. There may be another solution. A different study from Newcastle University says we could stop a pandemic by focusing on specific flights that span multiple high-risk locations. Though, as it stands now in our reality, we see no evidence of that happening. The US and China are currently using border screening to try and stop the spread. Back to the game. Things seem to spread pretty quick. We programmed the virus to mimic the real-world coronavirus that moves between animals and person to person through air. In 1918, the Spanish flu infected 500 million people and killed 50 million, 3% of Earth's population. Today, that's equivalent to 230 million people, more than all of France, Italy, and the UK combined. That happened fast too. The main pandemic wave began and was finished in just 8 weeks. The CDC is still gathering data, but it's thought this strain can survive on surfaces for several hours. SARS, a similar virus, was able to float through air currents and remain truly airborne for many hours. Just how airborne nCoV is will be crucial to figure out. Another issue here is increasing lethality. For simulation's sake, we began to add other complications, such as heart problems. It's debatable if this would actually happen. A 2006 paper from the National Institutes of Health found SARS created heart issues in the majority of patients, but they were mild, mostly elevated heart rhythm. By the end of the game, death tolls reached levels beyond what seemed possible, even under worst-case real-world projections. What's probably different about the game is intra-country disease transmission. In our world, even with an airborne virus, spread is likely to slow down when quarantine measures are in effect. We did throw a wild card into the game, though. Mutation to spread through contaminated water. So, could the new coronavirus go waterborne? Somewhat concerningly, scientists don't know. A 2015 study from the University of Illinois suggests it could transmit through drinking water, but, quote, evidence is inconclusive. What about Madagascar? Usually, that's the last country standing in these games. But not in this simulation. Roughly 100,000 Chinese nationals live on the island nation. Ivado, Madagascar's biggest airport, offers no direct flights to Wuhan, China, where the virus originated. However, a connecting flight is possible through several different airliners. Take a deep breath. This is no time to panic, but vigilance is important. SARS killed 800 people in 2002. And unlike today, travel was lighter at that time of year in China. And most importantly, the incubation period on SARS was short, sometimes just 2 days. Early data suggests the new virus sits longer in the body before showing symptoms, which may make it easier to stay hidden and spread. Again, the numbers in the game are not a prediction. In this simulation, the disease seems to spread inside a country faster than it would actually. But the bigger picture is very much relevant. Airports should consider shutting down high-traffic routes, and officials need to be monitoring the possibility this goes waterborne or already is. Links to the studies are in the description. If you like this content, subscribe and leave us a comment.